Hey guys, welcome to this two-part programmatic labeling series where we are going to build an end-to-end machine learning model using an unlabeled dataset. In part 1 of this series, we discuss programmatic labeling, the intuition behind, and Snorkel, which is a powerful open source tool used for programmatically creating and managing training datasets for machine learning models. Now in this part 2, we are going to see Snorkel in action. So here's what we are going to do in the next 10 minutes or so. First, we load our unlabeled dataset, which is YouTube comments dataset originally introduced in Tube Spam. Then we write multiple labeling functions or LFs, which are essentially Python programs. We shall discuss more on this in a bit. Then we combine outputs of our LFs to generate what we call as probabilistic training labels. And finally, we train a classifier that can predict if a given YouTube comment is spam or for real. Sounds good, right? Our YouTube comments dataset consists of YouTube comments taken from 5 specific videos. Our task is to classify each comment as ham, which means it's a relevant comment to the video, or spam, which means it's irrelevant or inappropriate. Most times, spam comments have promotional links in them. Second thing I want to talk about upfront is labeling function. Quite simply, labeling functions are Python programs that help users like you and me encode our domain knowledge and other supervision sources programmatically. Just to revisit, a while back I told you spam comments tend to have promotional links in them. So can I write a labeling function to look for web links in all unlabeled comments and flag all those comments as spam? If I can, that's a labeling function right there. And labeling functions can be noisy, which means they don't have to be perfectly accurate. Additionally, they don't have to label every data point by means of abstaining to vote. Moreover, different labeling functions can overlap and even conflict, which means they assign different labels to the same data point. All of this is expected, and I'll demonstrate how we deal with this later through majority vote or other techniques. We'll see. Now at this point, let's switch over to the Jupyter Notebook to start with our hands-on. Alright, we are in Google Colab now, and this is the structure of this code file that we have. First up, we are going to set up our environment using these lines of code, where first up we are installing these packages for Snorkel and utils. Snorkel obviously for the labeling purpose, and utils has the supporting functions that we would need. Post that, we clone Snorkel GitHub repo into our runtime. It entails the dataset we are going to use. So I'll run that as well. And with this cloning, you will see that in the files section, now we have this set of files copied within our runtime. Next step is loading the dataset. In this, we import this spam dataset from Snorkel built-in tutorial. You can instead use any dataset that you may have, but I'll highly recommend that you start off with this. Go through the entire process and then you jump onto a specific dataset you may have in hand. Over here, as you may see, we have defined 2 separate data frames, one for the training data and other one for the test data. Now let's look at the training data that we have. We have these 5 columns. Within this, column 3 is the YouTube comment text. Next up, let's look at the shape of our data. Our training data has 1586 data points. Here's the count of our data points across video 1, 2, 3, 4. We can also look at the test data set that we have. Again, it looks very similar to our training data. Lastly, here's the shape of our test data. This next section focuses on generating labels for our spam dataset. Within this first code cell, we define these three constants, ham, spam, and abstain, to represent the three class labels for legit comments, spam comments, and abstain when we are not confident on whether a particular comment is ham or spam. With this next code cell, let's explore if our dataset has some definite patterns that we observe upfront. You may also pause this video at this point to take a look for patterns yourself. As I can see, there are specific comments that have these hyperlinks in them, which means that the person who is commenting is putting these links with an intention of diverting the traffic to their respective pages. And there are many of these comments that have the phrase checkout, and checkout. So again, this is being done in a bad faith. And then there are these genuine looking comments, mind-blowing dance, where a person is appreciating the content. This one which is sort of a negative sentiment. So this is a high-level observation we may draw from these randomly drawn samples. Alright, in this section, we define multiple labeling functions or LFs that considers the pattern we just identified and try to generate weak labels. So to get started, let's load these helpful functions we'll be using at a later stage. And first up, we define our first LF called regex checkout. This searches for phrases starting with check and ending with out to flag them as spam. And if this phrase is not identified in specific data points, then this particular LF abstains from voting. Let's run it. Snorkel also provides us facility to use third-party models to build labeling functions. So over here, I loaded this text blob object and computed polarity and subjectivity scores for each comment. If you may recall, polarity is the sentiment of a given text. +1 represents positive, -1 represents negative, and 0 is neutral sentiment. And subjectivity quantifies the amount of personal opinion and factual information contained in the text and lies between 0 and 1. And this text blob sentiment acts as a preprocessor and is consumed later on by our labeling function, which is this text blob polarity. The logic we are keeping for this particular LF is that if polarity is more than 0.9, then this LF votes as ham, otherwise it abstains. Similarly, there is another LF called text blob subjectivity, which has this logic that if subjectivity is more than 0.5, then it votes as ham, otherwise again it abstains. If you may note, both of these LFs are not making any decision on the spam class. Because if you think about it, polarity is a good indicator of legit comment or ham. Genuine followers writing a YouTube comment would mostly want to appreciate the content. Alright, next up we have this function make keyword LF, which assigns a label to comment depending on if they have words like my, subscribe, http, please, or plz, or maybe song. And basis that, this LF labels them as spam. I'll run this one. And towards the end, we have two more LFs. First one is short comment, which votes any given text as ham if the length is less than 5. And then there is has person NLP. Logic over here is if a particular comment has mention of a person. Alright, now we move on to the next section. In the previous section, we defined a handful of LFs. Now it's time to apply these LFs on our unlabeled data. So let's do it through this pandas LF applier. Let's generate a quick summary for our reference. So these are all the labeling functions that we have defined and applied on our training and test data. And this is the performance of these LFs. Over here, coverage is the percentage of samples for which a given LF votes ham or spam. Overlaps mean the percent of data points labeled by multiple LFs. These LFs can assign the same or different labels. Conflict means percentage of data points that are labeled differently by multiple LFs. Now let's jump on to combine LF outputs with label model. In this section, we try to use information from multiple labels and try to generate a single label for each comment. For this, the first technique we use is, of course, majority vote. This simply looks at different labels assigned, and final label assigned would be the one which was voted for maximum times. Quite a democratic approach, right? And with this, we get our first set of data labels. However, if you think about it, our LFs have varying properties and should not be treated identically, right? Some LFs may be highly correlated, resulting in certain signals being overrepresented in a majority vote based model. To handle this, we use a more sophisticated Snorkel model to combine LF outputs. This approach ultimately produces a single set of noise-aware training labels, which are probabilistic or confidence-weighted labels. Since we have a test set available, let's look at accuracy of labeling for both these approaches here. To break ties, we are using random policy. As you may see, the accuracy from label model is more than 3% of the accuracy we are getting with majority vote. So the second approach seems like a better one to go with. Next up, let's filter out unlabeled data points. What this means is some of the data points in our training set didn't receive labels from any of our labeling functions. So obviously these data points convey no supervision signal and tend to hurt performance. So we filter them out before training. Let's do this. Now we are going to train our classifier. So finally, we have got the final label dataset, and we are good to move on to training a machine learning model based on this data. First step for this would be to represent our data in form of a vector. For this, we are using CountVectorizer here. Now let's train a simple logistic regression model on our dataset. We are getting a good performance score of 93.6%. Now, just to check how accurate our model is, I have these couple of YouTube comments that I wrote myself. Let's see what our model predicts on these two. As you may see, review number 1 is predicted as spam, and it's rightly so because it includes check out my channel, which is basically a spammy way of writing a comment. Second one is predicted as ham, which again is rightly done. So this completes our coding review. Guys, do try out this data labeling and modeling project by yourself to really internalize the learning. Link to this Jupyter notebook I'll put in the description part of this video. Whatever question, query or clarification that you may have, put them in the comment section below and I'll be more than happy to answer them for you. And do subscribe to my channel and help me reach 5,000 subscribers if you are liking my work so far. Also suggest me some new project ideas that you may want me to cover in the upcoming videos. Happy learning to you all. Bye.